In this video, we'll be looking at finding an unknown side of a right angle triangle where the unknown appears in the denominator of the equation. So before we begin, remember our ratios. We have sine theta equals opposite over hypotenuse, and we remember that by using SO. We have cosine, which is cos theta equals adjacent over hypotenuse. And finally, we have the tangent, or tan theta, equals opposite over adjacent, or TOA. So to begin, we operate in the same way as if we were finding a normal unknown side. The first thing you need to do is list the sides that have value. So I know we have a straight line from the right angle, so this is my hypotenuse, and then we have a curved arrow here where the side is between the right angle and the angle. So this is my adjacent. Now we have H and A. So if I write my SO, CA, TOA, I want you to circle the one that has an A and a H. So we're looking at this here. So we're looking at cos. And then I can write out the equation. So cos theta equals A over H. I substitute in the values we know. So cos 35.7 equals A, which is our 78.3, over our hypotenuse, which was the letter Z. Now, what we need to do there is, with this one, the trick is to remember that you just swap these two positions. Okay, so the unknown goes up and the cos goes down. Now the reasoning for this is because you will be multiplying by the Z to bring it up, and then you will divide by the cos 35. So if I multiply by the Z, I get Z cos 35.7 equals 78.3. I then divide by the cos to get Z equals 78.3 over cos 35.7. So that is the reasoning for this. The trick though, again, is just to remember you swap those two positions. So we get 78.3 over cos 35.7, and you put it into the calculator. And we get 96.4. Now it does have units, millimeters, so we'll put them in. Alright, so we'll do another one here. Same thing, let's start by highlighting what we have. So that's opposite because it's a straight line from 64, and a straight line from the right angle here means this is our hypotenuse. If I write SO, CA, TOA, we have an O and a H, so I know we're dealing with SO. So sine theta equals O over H. So sine 64, because we're just substituting in our values now, equals 93.7 over H. Now again, the trick, remember, is just to swap these two positions. So I'm left with H equals 93.7 over sine 64, which you can put straight into the calculator. And we get 104.25. Does it have units? No, so we'll just leave it as units. And there you go. And finally, we'll do one more. As always, start by highlighting the sides that have values. So here we have our opposite, and then we have any side between the right angle and the angle. So A, so, CA, TOA. We have O and A. So we're looking at TOA, which means we're using tan. So tan theta equals O over A. And now we do our substitution. So 38 degrees and 11 minutes equals 16.34 over T. Use our trick and swap those two positions. And we get T equals 16.34 over tan 38 degrees and 11 minutes, which you put in the calculator to get 20.8. Does it have units? Yes, in meters, so we put meters there. So to recap, remember you have your trigonometric ratios. So sine equals opposite over hypotenuse, and we use SO. Cosine is cos theta equals adjacent over hypotenuse, which is CA. And finally, tan is opposite over adjacent, which is TOA. And remember, our trick is if we have something such as sine 28 equals 8.4 over x. If we have the unknown on the bottom, you can swap these two positionings to get x equals 8.4 over sine 28. So that is the trick.